Today we are going to discuss the particulate nature of matter. As you know, that's the first topic in IGCSE chemistry. And here on the screen you can see the curriculum, the core and the extended curriculum highlighted. You know, the core curriculum, all of you have to learn the core curriculum. Extended curriculum is only limited to the students who are opting for the extended curriculum. I'm sure you know what core and extended curriculum means. And the first topic is all about matter, and it's interconversion of states of matter and the properties. There are a few properties we need to discuss, and as you can see, matter is the first definition of matter. That is anything which occupies space and has volume. It has volume and has mass. That is called matter. So examples you can see: solids, liquids, or gases. You know, they are all examples of these are the three states of matter. And in three different states, we can see the substances arranged with the examples. And as you know, there are more states, but we are not really going into the other states, which probably you may know. It is the supercondensed state and plasma state. We are not referring to them now. So thinking about the three states of matter and the examples, all students usually they ask, do we have an example of a substance which is not a matter? And I would say shadow is not a matter, and of course, and vacuum also, you can say two things which are not examples of matter. And how do you know they are not matter? Because they don't fall under the characteristics, they don't have the characteristics of matter. You know, that is why they are not. Now let us see how what are the properties of the states of matter. You know, it is summarized in the table. Before that, we will just see simulation. And in the simulation, we will see the three different states of matter and how do we interconvert them. Yeah. States of matter. Three different states, and this simulation, basically you can operate, you can see, you can do the experiment as if you're doing an experiment, you can do it. So let us just see. Let me change my picture from there so that you can do it better and you can view the controls very well. And as you see, there it is neon, or you can select argon, or you can select oxygen, or you can go for water. Let us start with the neon. It looks cool blue color. And as you know, it is solid state, and I'm choosing solid state. And if you want, I can choose liquid state. See, compare these two states. This is solid state. So you should compare this state to liquid state to gaseous state. These are three different states, and each one is a particle. Since we have selected neon, these particles are atoms. You know, because neon is a noble gas, it has only one atom in a molecule. So if you have oxygen selected, you can see that it will be molecules. Molecules means there are two atoms exist together. That's a molecule. For neon, atom and molecule, it's one and the same. It doesn't make any difference. So we are taking neon for simplicity. So start with the solids, liquid and gas. Remember, our discussions are going to be on how the particles are arranged. And what is the distance between the particles, arrangement, the distance, and also about the intermolecular forces between them. And we need to discuss together what about their movement of the particles in solid, liquid, and gas. So we will see this, and then we will later on summarize, take the summary chart, and we will see that as well. So this is liquid. So in solid you see a regular arrangement, but in liquid you don't see a regular arrangement. As in gas as well, there is no regular arrangement. So solid you say regular, irregular, irregular. And in solid they are closely packed, right? They are close together. Liquids, they are still close together. Many of them are touching each other, yeah? Yes, they are far apart. And of course the movement. In solids you can see the particles are still vibrating in their fixed position. Liquids, what do you see? Particles are moving. They are sliding past each other. That's the best word to describe. Slide past, yeah, each other. Random free movement of the particles. That's how you say. So we talked about three different aspects of solids, liquid, and gases. And of course, the forces of attraction holding the atoms together, you would say solids have the strongest force of attraction, right? Liquids have slightly less force of attraction. Gases have, we say, no forces of attraction holding them together. Okay, now let me take solid, and I'm slightly heating it. You can see when I push that button, where the control of heating, you can see it changed into a liquid and soon into a gas. And on top, you see the temperature increases. Temperature increases, and that's in Kelvin. You know, Kelvin is you have to add 273 to degrees Celsius. That is where you get. That's how you get temperature in Kelvin. It will increase. Okay, let us see. If you're interested, you can see till the point that its lid may go off. Okay, we will see that. At the same time, you see in this point, you see the particles of gases collide with the container, surface of the container. Yeah, these collisions bring in the pressure for gases. Just keep in mind. So this is another phase of it. It shows the interconversion states of matter, and it shows in a better way. I can keep on adding like more particles to that. When I pump in, I can pump in more particles. Okay, and if I cool, this is cool. I lower that temperature. I have the temperature control. You can see that I'm using my pencil. I'm bringing it down, and then I'm heating. I heat. See the temperature also and pressure. There is a pressure barometer as well. Let me move this one around. Now you can see the pressure. Please read the pressure as well. Pressure gauge shows 16, 17, 18, 19, and it increases, and so from solid it changes into liquid, and then the liquid it changes into gas as well, and its lid you can see someone is pushing and pressing the lid tight. Pressure is increasing, and so many atmosphere. If the now current pressure is 1 atmosphere, you can see on the pressure gauge the pressure keeps increasing. Of course, as the temperature increases, the particles or the molecules are moving faster. They collide with the container more number of times, and as the number of times increases, per unit area increases. That is called the collision frequency increases. Pressure is becoming tremendous. You can see, yeah, temperature. I'm increasing temperature. Pressure is 150. It's 180. It's more than 180. Yeah, and oh, the lid is gone off. Oh, that clearly shows the lid is gone off. So the pressure was exceeded the limit. That is why. If I want to restart, either I bring it back or I can do it resetting. Yeah, the same thing I can do for water molecules as well. Water molecules, they have a slightly different geometry when they are set into solid state, and of course, that discussion could be later. Yeah, and this also could be, you can do the same way. The site for this is URL is FET Colorado. Everybody can go into this site, and it is giving wonderful simulations on physics, chemistry, biology, and mathematics. So chemistry, it is very useful. I use it for my teaching, and it is interesting. And It's very good one. When I rate that's really good. All right, now let me move it slightly up. All right, so now I have the summary chart. Look at the summary chart. Arrangement of particles. Arrangement of particles in solids, liquids, and gases. I would say, yep. Okay, so that is regular arrangement, and in liquids, irregular arrangement, irregular or random. You know those words you can use. Particles are closely packed. You know, they are closely packed in liquids as well. You know, the space between them is very limited, far apart. Arrangement of particles, let me highlight it when the question comes in an IGCSE paper. How the particles are arranged, if they ask, you need to write these 2 points: regular arrangement and closely packed, and for solids, irregular or no regular arrangement, or it is irregular and closely packed in liquids, and irregular and far apart for gases. Movement of the particles, you know, I would like to highlight the main aspect. Vibrate, that's a key term. That's a key term you need to use. And you can see slide past each other. That's a key term there. Free random movement, you know, for gases. And can you use the word random here? I would say yes, that's fine, you know, because that is also a random movement. Just keep that in mind. Then moving on from here, spaces between the particles. Space between the particles, you know, no space or little space in solid, medium space, and maximum space in gases. Force of attraction between the particles, solids between the particles, the force of attraction is maximum. Whereas in liquids, the force of attraction is medium, and in gases, we say no force of attraction. You may have questions in your mind. You may say that why there is no forces, etc. As the course develops, you know, we will have discussions on that. In grade 11, we have much more discussion on this, the force of attraction between the particles in gases. For the time being, for your syllabus, we keep it as no force of attraction. All right, that is the first few points of discussion on solids, liquids, and gases. And now we talk about interconversion of solids, liquids, and gases. Interconversion of states of matter. You can see, yeah, 3 states. What terminology we use? What terms we use? Solid, solid getting converted into liquid, melting or fusion. Liquid to convert into gas, boiling or evaporation. And solid to gas, it's called sublimation. Yeah. And the next one is, I will take, the reverse one, solid, gas to solid, see the reverse sublimation or deposition, you know, we call it deposition as well. Gas to liquid, we call it condensation, right? And liquid to solid, it's freezing. It's freezing. All right. Now the solid to liquid melting. How do you define melting? It's a process of a solid getting converted into its liquid by heating. That process is called melting or fusion. Similarly, you can do the boiling and evaporation. There are differences between. We have the differences mentioned down there. You can see evaporation takes place at all temperatures. For example, for water, evaporation occurs at all even room temperature, below room temperature, and even at till the boiling. But boiling, it will occur only at a particular specific temperature. Example, again, if you take the liquid as water, it will boil at 100 degrees Celsius. Or else you can say boiling is the fastest evaporation, right? What about gases and vapor? You know, these 2 terms often you see the difference between gases and vapor, the term gas and vapor. Gas is anything which exists as a gas at room temperature. Example, hydrogen, oxygen, nitrogen, chlorine. They are all existing as gas at room temperature. But vapor is a term which refers to the gaseous state of a substance which is a liquid or solid at room temperature. Example, water vapor, because water exists as a liquid at room temperature. Iron vapor, because iron exists as a solid at room temperature. Alright, so if you know the state changes between this one, we have one video which tells us clearly the process of sublimation, which gives you a good video of process of sublimation. Let us just watch that. We are safe. Solid iodine, you could see solid iodine. Small crystals are taken and when it is heated, it changes. Iodine got its name from the Greek word, yes, means purple due to its color. Iodine vapor has beautiful purple color. Iodine directly changes into its vapor on direct heating. Flask containing ice. Let me tell you, the process of sublimation, again, it should be the direct conversion of a solid into its vapor on heating. It should not go into its liquid state. There is no process of melting. We skip melting as well as boiling, and direct change is called sublimation. Alright? So, and after sublimation, once the vapors are produced, you can see these vapors, we are trying to cool it down by bringing a round bottom flask having crushed ice in it. See, it hits, the vapors hit the bottom of the RB flask, which is really cold, and the cold surface bring the temperature of the iodine vapors down, and you can see a solid is formed, and this solid formed is called deposit, or the process is called deposition. All right. Beautiful iodine crystals are getting formed. Sorry. Yeah. So this experiment clearly shows us the process of sublimation and deposition. Yeah. So here we are. What it is? So we were just discussing the process of sublimation. That is sublimation, okay, sublimation. And the reverse sublimation, otherwise we call it deposition. Yeah, we can see that. Other processes, I'm sure you're familiar too. The processes of melting, ice melting. That is a first thing comes to everyone's mind. Melting of ice, and then freezing is freezing, water freezing, and that is in the refrigerator. In your refrigerator, in the freezer, freezing occurs. And soft drinks, you might have seen soft drinks. You keep in the cans, the closed cans, for immediate cooling, and later on someone forgets, and it definitely it will break the can open. It will break the can because of the expansion. That's not in our scope to discuss at the moment. Kinetic particle theory. You know that the next topic says I should explain kinetic particle theory, and use this kinetic particle theory to explain the process of melting, boiling, and sublimation, and the reverse process of all of that. Say, what are the main postulates of kinetic particle theory? Every substance is made up of extremely small particles, and these particles are called atoms or molecules. Particles of the same substances are similar, and they are similar in size, mass, and volume, etc. In every aspect, they are similar. Particles of different substances are different in size, mass, volume. They are all different. Particles are never at rest. In solids, they vibrate. In liquids, they slide past each other. In gases, they move randomly. As the temperature increases, the particles vibrate or move faster. These points are very important for us to explain. Explain the process of melting. In IGCSE, I would say there are if they ask the question, GCC exam, if they ask the question, explain the process of melting on by using kinetic theory, these are the two scoring points. Particles, when a solid is heated, the particles gain more kinetic energy and vibrate faster. Given in bold, that's 1 point. That's where you score the first mark. And they break some of the bonds between the atoms or the particles. That's the second point. So you get 2 points if you explain this way. Particles gain more energy and vibrate faster, and they break some of the bonds and they change into its liquid. What about now the liquids when heated? That is the next one, boiling or evaporation. How do you explain? So you explain it in a similar way. Particles gain energy and move faster. If you have noticed, I use the word move here and I use the word vibrate in the first case. Because in solids they only vibrate, whereas in liquids they are moving. Of course they are vibrating as well, but movement is more significant. Translatory movement is more significant. So we choose the term move, and they start to move faster, leaving their permanent position. And it was in solid breaking some of the bonds, whereas in liquids, when you heat a liquid, they break off all the bonds. Bonds are forces holding them together in solid state or holding them together in liquid state. But there is no such bond holding them in gaseous state. So, when a solid changes into a liquid, some bonds are broken. When a liquid changes into gas, all bonds are broken. This is what is, and the phase change melting and the phase change boiling explained based on kinetic theory. 2 marks, and these are the explanations for 2 marks. Okay. Now, the reverse of it, or even sublimation. If you have to explain sublimation, you need to use the term particles. When a solid is heated, particles gain more kinetic energy or energy and vibrate faster. They break, instead of some, you need to say all the bonds. That is when you have to explain sublimation, right? Then, and change into, instead of liquid state, you say into its gaseous state. Then, if you have to go back, everything should be reversed. Say, for example, melting you want to reverse. Reverse of melting is freezing or solidification. They set into its solid state. So what are the 2 points? When a liquid is cooled, its particles in liquids lose energy. They lose energy and they move slower. Lose energy and move slower. Then, instead of break some bonds, they make more bonds between, and they come closer. They change into its solid state. Just reverse of all these points. What about condensation? Condensation is when a gas is cooled, its particles again lose energy. They move slower and move closer. 2 points you can say, move slower and move closer. Then they say there are more bonds are getting formed. Bonds are being formed between the particles and they condense, they change into its liquid state. That's all from me today, first lesson.